Good morning, students. Today we are writing some number patterns and we are generalizing it, or the general form of the number pattern we are writing. We are finding out the general form of the number pattern using algebraic expression. See the number pattern 12, 23, 34. 34. They are starting with the 12, and if we add 11 we will get 23. If we again add 11 we will get 34. If you continue add like this, so the numbers till 100 you will get, that is 12, 23, 34, 45, 56, 67, 78, 89, 100. So starting from 12 we are adding 11. Then if you continue further, would we get 1000? Okay, if 1000 is included in this number pattern, so it is not easy to find out like this. Instead of that, we can write 12 as 1 more than 11. 23 is 1 more than 22, that is a multiple of 11. 34 is 1 more than 33. 33 also multiple of 11. So that multiple of 11, and if you add one more, we will get this numbers 12, 23, 34 like that. So all our numbers got by adding 1 to the multiple of 11. In other words, you can say if they all leave remainder 1 by dividing 11. If you divide 12 with 11, we will get remainder 1. If you divide 23, remainder will get 1. 34 also will get remainder 1. Or either by adding 1 to the multiple of 11, or by leaving a remainder on dividing by 11. 1000 is included in this. What do you have to do? If you divide 1000 by 11, 11 9s are 99, remainder 1, 10. So this will not be a part of this pattern because the remainder you got 10 here. You can see that if you divide 1000 by 11, you are not getting a remainder as 1. Okay, so 1000 is not among these numbers. Okay, 1000 is not among these numbers. So if you divide with a common number and you are getting a remainder 1, that number should be included in this pattern. First note that all these numbers were got by starting with the 12 and adding 12 repeatedly. That we see first. Then we can write an entire pattern for this operation, or this entire number pattern could be written as a single operation. So using algebraic form you can write down. So multiply all natural numbers by 11 and add by 1. That you can write like this in algebraic form. That is 11n plus 1. 11n plus 1. 11 is multiplied with 1 and one more number is added. So you will get the first number. 11 into 1. 11 into 1 plus 1. What you are getting? 12. 11 plus 1, 12. Next, 11 into 2 plus 1. 11 into 22, 22 plus 1, 23. 11 into 2, 11 into 3 plus 1, 33 plus 1, 34. So you got the same number pattern. So we can write this number pattern as common, that is 11n plus 1, where n is the natural numbers 1, 2, 3. In algebraic form, that number pattern we can write as 11n plus 1. Instead of 12, we are writing with the starting with the 21 and adding 11 again and again. So the next number what you are getting? 21 plus 11, you are getting 32. Again if you add 11, you will get 43. 11 plus 10, you are getting 21. 22 plus 10, you are getting 32. 33 plus 10, you are getting 43. So like that you will continue. So in algebraic form, how will you write? These are the multiples of 11. So 11n plus how much? What is added? 10 is added. Where n is equal to 1, 2, 3, etc. Values for n, we get the multiples of 11. So you can get the algebraic form as 11n plus 10. This number pattern we can write in algebraic form by 11n plus 10. See the patterns we studied. Okay, 12, 23, 34, 45. Multiple of 11 in the added 1. Then 21, 32, 43, 54. So that is 11, multiple of 11 and added 10. If you add this pattern, that is the top and bottom numbers in order, you have to add it. 12 plus 21, you are getting 33. 23 plus 32, you are getting 55. If you add this one, you will get 77. If you add, you will get 99. So you will get a pattern like this. The first pattern is 11n plus 1. The second pattern is 11n plus 10. Then what you will get if you add it? 11n plus 11n means 22 n you are getting. So by adding 11n plus 1 into 11n plus 10, what you are getting? 22n plus 10. This you can write is like this. If you write the common number outside, not 10, it is 11. Okay, 22n plus 11 you are getting. Okay, 1 plus 10 is 11. So 11 as common. So 2n plus 1 we can write. 11 into 2n plus 11 into 2n is 22. 11 into 1 is 11. So the common, the third pattern, this third pattern we can write it common like this. 11 into 2n plus 1. If you add 1 for n, then what you are getting? 11 into 2 plus 1 is 3. So answer you are getting 33. So the first number. Then 11 into 2 into 2 plus 1 is equal to 2 into 4. 4 plus 1 is 5. 5 into 11, how much you are getting? 55. So the same pattern you are getting in this form. Okay, 11 into 2n plus 1. That is the algebraic form of the third pattern. So from the third pattern, we are getting only the odd multiples of 11. We are getting it because 2n plus 1. If you give 1, 2 into 1 plus 1 is 3. Then if you give 2, 2 into 2 plus 1 is 5. 2 into 3 plus 1 is 7. So these are the odd numbers. That's why you are getting the odd multiples of 11. So in generally, we are writing these patterns. Okay, 2n plus 1 or 11 into 2n plus 1 or 11n plus 1, 11n plus 10. Okay, these are called algebraic expression. A number pattern we can write in this algebraic expression. Find the algebraic expression for the numbers got by adding 10 repeatedly to 1. That is, from 1 you have to add 10. Again you have to add 10 like that. Adding 10 repeatedly to 1. You are getting 11. Again 11 plus 10 we are getting 21. 21 plus 10 we are getting 31. So like this the pattern will increase. So you are getting the numbers as 11, 21, 31, 41, etc. Okay. So you are writing a common form for this algebraic expression. So the same 11 we can write like this. 10 into 1 plus 1, that is 11. Okay. Then next 21. 10 into 2 plus 1. 10 into 20, 20 plus 1 is 21. 31. I will write 10 into 3 plus 1. So we are writing this number pattern in a common way. Okay. 11 is equal to 10 into 11 plus 1. So 10 multiplied by a number a number n, we can write and add it 1. So you can write this pattern as 10n plus 1. Okay, n is equal to 1, 2, 3, etc. So this pattern we can write in a common form, that is called algebraic expression. So the algebraic expression of this number pattern is 10n plus 1. 1 is added, 10 is added repeatedly to 1. Okay, so you are writing 10n plus 1. Find the algebraic expression for the numbers got by adding 10 repeatedly to 9. Instead of 1, 9 you have to add it. Okay, 10 repeatedly to 9. Pattern 9 plus 10 equal to 19. Again 19 plus 10 you are getting 29. 29 plus 10 you are getting 39. Like this it will increase the numbers. So from 9 it is starting and 10 is added repeatedly. So the numbers you are getting 19, 29, 39, etc. So in common, how will you write 19? 10 into 1 plus 9. 9 is from 9, 10 is added. So you are getting 19. 29. 10 into 2, 20 plus 9, 29. 10 into 3 plus 9, 39. So like this the pattern will increase. So you can write in common 10n plus 9, where n equal to 1, 2, 3, etc. Okay. So this is the algebraic expression for this pattern. 10 into n plus 9, where n equal to 1, 2, 3, etc. Instead of n, you can take any alphabet. Okay. This is a number, that's why I wrote n. That's all. Add the numbers in the same position of the first two patterns. These two patterns, if we add it, then why do we get only multiples of 10? Do we get all multiples of 10 like this? So we have to add these patterns and see what is happening. These are the number patterns. The first pattern we wrote as 10n plus 1. The second pattern we wrote 10n plus 9. Next, add the numbers in the same position. Okay, so 1 plus 9, 10. So we'll get 30. We are getting 50. Next we are getting 70. Next we are getting 90. So 30, 50, 70, 90 it will go. Then what happen if we add this one? 1 plus 9, 10. 10n plus 10n. We are getting 20n. So 20n plus 10. This you can write in common. 10 outside, what will get? 10 into 2 is 20. So 2n. 2n into 10 is 20 plus 1. So 10 into 2n plus 1. We can write in common. The numbers you are getting is the multiple of 10 itself. Okay. Common algebraic form you can write like this. Okay. We are getting a multiple of 10. Multiples of 10. 10, 20, 30 like that. Okay. In common we can write 10 n, where n is equal to 1, 2, 3 up to 9. Similarly 11, 21, 31, etc. got by adding 1 to the multiple of 10, that is 10n. In common you can write 10n plus 1, where n is equal to 1, 2, 3 up to 9. N is a natural number. Okay, remember that one. If you need only a 2-digit number, we can write n is equal to 1, 2, 3 up to 9. Otherwise, continuously we can take it. If it's up to 99, so we will take 9 itself. A 2-digit number if we need, we will take n as 1 to 9. By adding 2 to the multiples of 10, we will get like this: 12, 22, 32 like that. In common you can write 10n plus 2. So you can see these three patterns: 10n, 10n plus 1, 10n plus 2. So all these patterns we are getting a 2-digit number. And if you want all 2-digit numbers, which is the algebraic expression should we write? 2-digit number means from 10 to 99. So if you need only 2-digit numbers, this pattern should write 10n, 10n plus 1, 10n plus 2, up to 10n plus 9. Okay, if you need only 2-digit number, these are the patterns we are using. 10 into 1, 10, 10 into 20, like that. Okay, 10 into n plus 1. So 10 plus 1 is 11. Okay, this is 12, like that will increase. So these are the pattern for a common pattern for to get a 2-digit number. 1, 2, 3 up to 9 we are adding. So these numbers we are taken common. Okay, the numbers from 0 to 9 we are taken common as m. Then how will you write this pattern generally? You can write 10n plus m. Okay, so 0 to 9 we are considering as m. So you can write commonly there 10n plus m, where n equal to 1, 2, 3 etc. up to 9, and m equal to 0, 1, 2, 3 up to 9. Okay. 0, 1, 2, 3 up to 9. So this is the common equation to get a 2-digit number. Here we are giving two values, n equal to 3, m equal to 5. Then how will you get this? 10n plus 7 become 10 into 3, n is 3 plus m is 5. So you will get 30 plus 5, we are getting the answer as 35. By giving the values for n and m, we can find out a 2-digit number. In the first place that is n, and the second place that is in m. Write a 2-digit number 25. Then reverse the digit and write the number. Reverse the digit means here 25, by reversing you will get 52. Then if you add these two, what you are getting? 5 plus 2, 7, 5 plus 2, 7. So 77 you got. Then what about this number? 36. On reversing we are getting 63. By adding we are getting 99. Then what about 28? If you reverse you will get 82. You are getting by adding 1, 10. In all these three cases you are getting the multiples of 11. Okay, here 7 into 11, 9 into 11, 10 into 11. All these three cases we are getting the multiple of 11. First place and the second place we are interchanging. That is why you are getting like this. We are getting by adding. If you take a number and reverse the number and add it, we will get the multiple of 11. We are writing this in algebraic form. A number we can write as 10m plus n. On reversing the number, it will be 10m plus m. 10n plus m. 10m plus n. By interchanging we get 10n plus m. And these numbers we are adding together. We are writing the algebraic form of this. Okay. So if you add this one, what you are getting? 10m plus m, 10n plus n. So 10n plus m is 11m. Here 11n. That is 11 into m plus n. So if you write a 2-digit number and by interchanging, and if you add these numbers together, you will get the multiple of 11. Then if you take the reverse, if you subtract this, you are taking same 25 and interchanging the number, you are get 52. If you reverse, if you subtract it, what you are getting? You got 27, then 63. By changing you will get 36. If you subtract it, you will get again 27. Next 82. If you reverse, you will get 28. Any common relation? These all are multiples of 9. So you are writing in algebraic form. 10m plus n. You got a 2-digit number. Then you subtract by interchanging the digits. Okay. What you are getting? 10m minus into plus minus m. Then or directly we write 10m plus n minus 10n minus into plus minus m. Then same numbers written together, 10m minus m plus n minus 10n. So 10m minus m is 9m. Then n minus 10n minus 9n. So 9 should be common, m minus n. Okay, this is general form. If you take a 2-digit number and if you reverse and subtract it, you will get the multiple of 9. Do some more examples. We are taking 27. We are taking the number 27, and if you interchange the digits, you will get 72. And if you add it, we are getting 99. So it is a multiple of 11. Then another number, if you are taking 72, then if you interchange, you will get 27. If you subtract, you are getting 45. That 45 is a multiple of 9. If you add it, you will get a multiple of 11, and if you subtract, you will get a multiple of 9. While subtracting, remember that one, you have to subtract from higher number to lower number. Then if these two numbers are added, 99 plus 45, the answers, okay, if you add it, you will get 144. And if you subtract it, 99 minus 45, so you will get 54. By adding, you will get 144, and by subtracting, you will get 54. Then see this 144. 144 is 2 times 72, and 54 is 2 times 27. That is also another specialty. Okay. If you take 72, if you take the double, you will get the by adding these two numbers. Okay. If you take the subtraction, you will get the double of the smallest number. Take any 2-digit number and add the digits. Subtract the sum from the number. Do this for several numbers and find a common property of all such differences. Take a 2-digit number and add the digits. Then subtract the sum from the number. A 2-digit number is equal to 35. Then add the digit. So 3 plus 5, you are getting 8. Then you have to subtract it from that number. Subtract it from the number. Then it is 35 minus 8. We are getting 27. Then another 2-digit number, 46. If you add the digits, 4 plus 6 is equal to 10. Then 46 minus 10, we are getting 36. So another number, 29. So 2 plus 9 is 11. And 11 should be subtracted from the number. So you are getting 18. What is the speciality of these numbers? 27, 36, 18. These all are multiples of 9. Okay, all these numbers are multiples of 9. That is a speciality. If we subtract any two-digit number, the sum of its digits, we get a multiple of 9. Explain why this is so using algebra. For using algebraic method, you have to explain it. Algebraic form of two-digit number, we can write as 10a plus b, 10m plus n, anyone you can write down. Then if you add the digits, that is a plus b, add digits are added, you are getting a plus b. Then you have to subtract from the number minus digits, sum of digits. So you going to, number is 10a plus b minus the digits are added, a plus b. So 10a plus b minus a minus b. 10a minus 9a, sorry, 10a minus a is 9a. Minus b plus b is cancelled. So you are getting the answer as 9a. So multiple of 9. So the difference is the multiple of 9. That is the answer. Difference is a multiple of 9. Take a two-digit number, add the digits, then subtract it from the number. So you are getting multiple of 9. Write the general algebraic form of all three-digit numbers. A three-digit number means it is from 100 to 999. Okay, there is a three-digit numbers. Now we will write the common. It is 100 n plus m. 100 n plus m, where n equal to 1, 2, 3 to 9 and m equal to 0, 1, 2, 3 up to 9. So this is the common form or algebraic form of a three-digit number, 100n plus m. If the first, second, third digits of a three-digit number are taken as m, n, p, how do we write the number? Using m, n and p, you should write down a three-digit number. Then how do we write the number got on reversing the digit? On reversing the digit, you have to write down the number. So the first, second and third numbers are n, m and p. Then you have to write a three-digit number. So it is 100m plus 10n plus p. First place, 10th place and 100th place. So three-digit number we can write as 100m plus 10n plus p. Then if you reverse the number, what is the number? The digits are reversing. Okay. So 100p plus 10n plus m. So by reversing the digits, number should be 100p plus 10n plus m. See an example. 1, 2, 3. That is 123 is the a three-digit number. By reversing the digit, what you are getting? 3, 2, 1. Okay. By reversing, you will get like this. 321. The 10th place is not changing. Only first and 100th place is changing. If we reverse any three-digit number and subtract the smaller from the larger, we get a multiple of 99. reverse any 3-digit number and subtract the smaller from larger, we get a multiple of 99. Explain using algebra. A 3-digit number, it is 100a plus 10b plus c. So a, b, c are the 3 digits. Okay. So 3-digit number we can write together 100a plus 10b plus c. Then if you reverse it, what you are getting? If you reverse, the number become 100c plus 10b plus a. Then next one, you have to subtract it from bigger number to smaller number. Okay. Subtract the smaller from the larger. So 100a plus 10b plus c minus 100c plus 10b plus a. So it is 100a plus 10b plus c minus 100c minus 10b minus a. So 100a minus a, it is 99a. 10b minus 10b, that is cancelled. Then c minus 100c. So 100c minus 1 is minus 99c. So this we can write as 99 into a minus c. So you have to take a multiple of the 99 into subtract from the first digit and the third digit. See one example. A 3-digit number I am taking 1, 2, 3. If you reverse, you will get 321. Then if you subtract a bigger number to smaller number, 1, 2, 3, 8, 9, 1. Then you are getting 198. That same 198 you are getting like this also. This you consider as A, B, C. A equal to 3 and C equal to 1. So 99 into A minus C is 3 minus 1. 99 into 2. What is that? 198. This is the algebraic form. 99 into A minus C. For any 3-digit number, if we subtract the sum of its digits, we get a multiple of 9. Explain using algebra. From any 3-digit number, if we subtract the sum of its digits, we get multiple of 9. Sum of 3-digit numbers 100a plus 10b plus c. Then which are the numbers? The numbers are a, b, c. Then sum of digits. Sum of digit equal to a plus b plus c. So this is a 3-digit number. From the 3-digit number, you take the numbers. Okay, first, second, and third digits. If you add it, a plus b will get, a plus b plus c will get. Then you have to subtract it from this number. So subtract the sum of digits from the 3-digit number. 3-digit number is 100a plus 10b plus c minus sum of digits a plus b plus c. So 100a plus 10b plus c is minus a minus b minus c. So 100a minus a, 99a. 10b minus b, 9b. And c is cancelled. So you are getting 99a plus 9b. Out of that, 9 is taken outside. 99a. To get 99, 11 should be multiplied. 11a plus b. So it is a multiple of 9. It is a multiple of 9.